Yes, my dear friends, good morning to each and everyone. Today we are going to discuss about the materials, metals and non-metals. So today we are going to discuss this topic, isn't it? Okay, my dear friends, before going to these points, we will discuss some of the points. Metals and non-metals, isn't it? Metals and non-metals. Here in your home, so many materials are there. Plastics are there. Utensils are there, steels are there, like this so many metals are there in your home. Already you people are using, isn't it? So many metals are daily you people are using all these materials. Some are made by metals, some are made by non-metals, isn't it? So we are going to discuss about the metals as well as non-metals. Yes, so these are the points: occurrence, metalloids, physical properties of metals and non-metals. So these are the points we are going to discuss, isn't it? So first we are going to discuss about that occurrence of the metals, isn't it? My dear friends, occurrence of the metals, some metals they occur in free state and some metals occur in combined state. Some metals occur in combined state. It means compound state. Okay, they are mixed with some of the other element because some metals are reactive in nature. They combine with other elements, other metals or other non-metals. That is why they occur in combined state, isn't it? So you can say it is compound also. Compound form we are going to get in the nature. Yes. Even non-metals also we are going to get in the nature. In the earth crust, my dear friends, some are free state. Non-metals, especially non-metals occur in earth crust. They are free state as well as combined state. So most of the non-metals they occur in a free state only. I think you observed nitrogen, hydrogen, helium, krypton, xenon. So these are the some of the non-metals. So these are occur in the nature free state, completely free state. Okay, and so only few are there. They are occurring combined state, isn't it? Yes, my dear friends. I hope you observed regarding the noble gases. Noble gases. I hope you know very well noble gases. Noble means rich. It means they completely free. They are completely free. Okay, noble gases. What are those noble gases? Helium, argon, krypton, neon, hydrogen. So these are the water noble gases. Rich. They are rich, isn't it? Okay, this is about water regarding the occurrence, isn't it? They occur in combined state, I told you, and these are also called minerals. These are also called minerals because they are occur in combined state, isn't it? Okay, free state, combined state, these are also called minerals. Okay, same way non-metals they are also occurring in free state and as well as combined, especially noble gases. Okay, helium, hydrogen, xenon, krypton, argon. So these are the some of the elements, isn't it? This is about what regarding the occurrence. I hope point is clear regarding this. Yes. Let us see that next point is what are metalloids. What are metalloids? Isn't it? My dear friends, metalloids. What are metalloids? Isn't it? My dear friends, there are so many metals are there. There are so many non-metals are there. Both metals and non-metals. There are some metals and non-metals. They possess properties of both metals and non-metals. Both metals and non-metals. Okay, there are some substances they possess properties of both metals and non-metals, isn't it? Okay, these are called metalloids. These are called metalloids, isn't it? Okay, they possess at room temperature. You should be remember this point. At room temperature. At the room temperature. Okay, they possess both metals and non-metals properties at room temperature. Such substances are called metalloids. Examples, okay? Examples: silicon, boron, arsenic, okay? Phosphorus, silicon, boron, phosphorus. Next, germanium. So these are the some of the water example of metalloids. Isn't it? Okay. Whole point is clear. What are metalloids? Isn't it? There are some elements, there are some substances that possess the property of both metals and non-metals at a room temperature is called metalloids. Isn't it? Okay. Example for the metalloids: silicon, boron, arsenic, germanium, and so on. Okay, these are the example of metalloids. Yes, my dear friends, next point is, that is physical properties of metals and non-metals. Physical properties of metals and non-metals. I hope point is clear, isn't it? So we will discuss one by one. We will discuss one by one physical properties of metals. Physical properties of metals, isn't it? So what is meant by physical here? Physical means what? Physical means what? So we have to discuss about that. Physical means what? See here, physical. Physical means according to you. Okay, physical. So existence, in which state existence? Are they solid? Are they liquid? Are they gaseous state? Are there any other states? Okay, this is what a physical. Physical properties of metals and non-metals. Physical properties of metals and non-metals. Right? Okay. So first property of that physical properties. First property, isn't it? So first property is what? A physical state. Physical state. Physical state means, already I told, physical means existence. In which state? Okay? It is in a gas, it is in a solid, it is in a liquid state, or any other state, or combined state. Okay? So this is what a physical state. My dear friends, most of the metals, they are solid in state. Solid in state. Most of the metals. Okay? Most of the metals, they are solid in state, and only few, mercury and gallium. So these are the liquid state. These are present in liquid, except these two. So rest of the metals, they are solid in state at a room temperature. In a room temperature, they are solid. They are not in liquid, except these two metals, isn't it? So mercury and gallium, these are the two metals. They are present in liquid state, isn't it? Okay, this is the first point of the physical properties of metals and non-metals. So next point, that is what next point, hardness or strength. It is also called strength. My dear friends, when you observe the metals, you know very well, when you touch the metals, when you felt the metals, when you touch the metals, you already know that metals are hard in nature. Metals are hard in nature, isn't it? Usually they are hard in nature. Usually all metals, any metals you have to take, only some of metals are there. Some metals are there, they are liquid state, some are soft in nature also are there. But most of the metals, 95% metals, they are hard in nature. Strength is good. Very hard in nature, isn't it? Okay, hardness. Usually hard in nature. usually hard in nature. There are some metals, they are soft in nature. Sodium, okay, potassium. So these are the metals, they are soft in nature, my dear friends, and these are reactive also. These are reactive also, very reactive. Okay, when it kept outside, my dear friends, these are very reactive, and they can react with oxygen, they can react with water, they can react with moist also. Isn't it? Hence these metals are stored in kerosene. These metals are stored in kerosene because of reactivity, high reactivity. Okay, if you kept outside, what happens, my dear friends? This sodium and potassium, they can start the reacting with oxygen, reacting with moist, reacting with water also. That is why we are going to store in kerosene. Isn't it? Yes. And these are very soft metals. These are very soft metals, can be cut by knife. Okay. Usually the metals are hard in nature. Yes. Next point is what? Lustrous. Okay, lustrous means what? According to you, lustrous means what here? Isn't it? Okay, lustrous means, my dear friends, it is shining in nature. Shining. It is a property. Shining in nature. Most of the metals, not most of the metal, all metals, they are shining in nature. They can shine. Okay, of course, so many people, they are thinking, so metals are reacting with oxygen, metals are reacting with other kind of materials, and they forms oxides. Okay, it is correct. But when we prepare the metals, when we extracted the metals, that time they are shining in nature. Later they undergone some of the chemical reactions and they turns the other colors. Okay, usually they are shining in nature, lustrous. Shining in nature, lustrous. Isn't it? Shining property. Yes? Whole point is clear. Isn't it? So physical state, hardness, lustrous. So these are the three properties we have discussed. Next point is what? Very important point, that is malleability. Yes, my dear friends, you can take the one nail. And one hammer. By the help of hammer, you can beat it strongly. Okay, so you can beat it strongly. At one stage, the nail turns into sheet. Isn't it? Turns into sheet. Okay, it means you can take any metal. Most of the metals are there. You can take any metals, my dear friends, you can beat it and turns into sheet. It means the property in which metals can be bitten into thin sheets is called malleability. Isn't it? Most of the metals, they are malleable in nature. Isn't it? Most malleable metal is gold. Malleability. Isn't it? I repeat once again. Malleability means, my dear friends, it is a property in which metals can be bitten into thin sheets. Such a property is called malleability. Isn't it? Most malleable metal is gold. Okay, we can make sheets. Very thin sheet we can make, like paper. We can make the sheet. Isn't it? Okay, this is what a malleability property. Next property, that is ductility. Okay. Fifth one, that is ductility. Yes. My dear students, you know very well malleability. Already we have got. What is malleability? Same way ductility. Ductile in nature. Ductility means, my dear students, say you have to take the one hammer, or you can drawn into wire. Of course, here also you can make the sheet also, no problem. But here you can draw into wire. You know very well copper wire. You know very well aluminium wire. You know very well silver wire. Okay, steel wire. Like this, so many wires you already observed. So these wires, because of ductility, it is also one property. Yes, my dear friends, ductility means it is a property in which metals can be drawn into wire. Such property is called ductility. It means metals are ductile in nature. We can convert the metal into wire. Such property is called ductility. And most ductile metal is silver. Isn't it? We can very thin wire we can make it silver. Whereas most malleable gold sheets, I think you observed, aluminium sheets, aluminium foil, silver wire, copper wire, aluminium wire, I think you know very well, tungsten wire. Okay, like this so many wires are there, we can make by this property. This is the property. Yes, my dear students, we have completed 5 properties. So first property, physical state. Second property, that is hardness. Third property, lustrous. Fourth property, malleability. Fifth property, ductility. So we have completed 5 properties. Next, sixth one we will discuss one by one. Okay, hope point is clear. Isn't it? These are the 5 properties. Isn't it? Yes. Next property. Next property is, that is, my dear friends, sonorous property. Sonorous. Sixth one, sonorous. Yes, my dear friends, imagine that you have hold a coin. And just you can drop it downside. You will get some noise, some sound you will get. Same way, you have to take the one plastic scale and drop like this. You will get the noise. So just check both the noise. When we drop the coin, when you drop the scale, what type of sound you can hear, you can check that, you can compare that, which sound is more audible, you can focus on that. My dear friends, it is one more property, sonorous property, the property in which metals can make sound. This property is called a sonorous property. Isn't it? This property is called sonorous property. Okay, we can clarify by taking the one scale, by taking the one coin or metal scale. You can take plastic scale and metal scale you can take, and you can drop at that time. My dear friends, you will get the sound. What type of sound metals and what type of sound non-metals on that plastic scale you will get. This is the property, sonorous property. Usually metals can make the sound. This is what the sonorous can make sound. Next property is that is conductivity. Seventh one, conductivity. Conductivity or conduction. Isn't it? Yes. My dear friends, you know very well regarding the metals, they can conduct the heat and electricity. We can conduct the heat and electricity. Heat and electricity. Heat and electricity. So for this purpose we have to focus one activity. Take one cell, one bulb, okay, here you can make the one switch also and connect the wire, okay, it is a cell, it is wire, one bulb, okay. Usually wire is made by copper or aluminum or any metal, isn't it? It is a switch and it is a shell, okay. By this activity we come to know that whether metals conduct the electricity or not, okay. Very simple, my dear friends. On the switch you will get the light will start the glowing, By this activity we come to know that metals conduct the electricity. Very simple. And you know very well, my dear friends, in your home electric circuits are there, and when you on the buttons you will get the light, you will get the fan, you will get the cooler, you will get the water, whatever electrical devices are there, they are working on the electricity. It means the metals conduct the electricity, isn't it? Yes. So this is about what regarding the conductivity. And come to the point, heat. Okay. Conduction of heat. Very simple, my dear friends. Take one metal scale and start the heating one side. Start the heating certain time, 5 minutes or 6 minutes you can start, and slowly you will feel hotness other end. One side you have to heat, another side you will feel hotness after some time. It means the metals conduct the heat also. Okay, best example while making food you will get it. Best example. Okay, one more example I am going to take. While making the tea, we are going to keep one vessel. Inside the vessel we are going to take milk, water, sugar and tea powder and all. We are going to prepare the tea. It means the heat we are going to supply to the vessel. So vessel will supply to the water. It means heat is a transfer from heat source to vessel to tea, so that tea can start the boiling. It means the tea get ready, isn't it? So by this activity we come to know that the metals are conduct the heat. Totally, my dear friends, conductivity, conduction of metals. It means metals can conduct heat and electricity. Yes, whole point is clear, isn't it? Next point is water, that is melting point and boiling point. Eighth one, melting point and boiling point. MP and BP. MP means melting point, BP means boiling point. Okay? Yes. My dear friends, listen here. MP means melting point, BP means boiling point. What is melting? What is melting point? What is melting? Next melting point. Two terms are there here. Melting means what? Melting point means what? Boiling means what? Boiling point means what? Okay, these are the two terms, and later we come to the property of melting and boiling point. Yes, melting means, my dear friends, it is a process in which the solid starts convert into liquid state. Solid start convert into liquid state. That is called melting. Okay, imagine that ice piece is there. You can keep outside ice piece certain time. It will start, after a certain time it will start the melting slowly. It means the ice is using the or absorbing the heat from the surrounding, isn't it? Okay, that is what a melting point. Melting point means what? The temperature at which the substance starts melting. It means at what temperature the substance starts melting, that point is called melting point. Isn't it? So dear friends, you know very well the melting point of metals, melting point of non-metals. Isn't it? Yes. Next, my dear friends, BP means boiling point. Boiling means what? It is a process in which liquids start convert into gaseous state. Okay, I will take solid starts liquid. It is MP. Okay, liquid starch gas, it is BP. Okay, solid convert into liquid, that is called melting, and liquid convert into gas, that is called BP. It means boiling point. Okay, I repeat, what is melting? The process in which solid convert into liquid state, that is called melting. What is melting point means, my dear friends, the temperature at which solid starts converting into liquid, that point is called melting point. Next, boiling means the liquid start converting into gas. The point where liquid start converting gas, that point is called boiling point. You know very well, usually the boiling point of water is 100 degrees Celsius. So 100 degrees Celsius means what? Yes, usually we are telling 100 degrees Celsius. The boiling point of water is 100 degrees Celsius. What is this? 100 degrees Celsius means what? We are telling 100 degrees Celsius, 100 degrees Celsius, 100 degrees Celsius. What is that 100 degrees Celsius means? Okay, when we supply the heat to the water, the system attains the 100 degrees Celsius. That time the liquid start the converting gas. Okay, and that point is called boiling point. That is why we are going to say 100 degrees Celsius. Isn't it? 100 degrees Celsius. That is why the boiling point of water is 100 degrees. But it is not same in all the cases. Okay, the boiling point of metals is different, the boiling point of non-metals is different, the boiling point of milk is different, the boiling point of oil is different. So different metals, they are having the different boiling point as well as melting point. Okay, I am coming to the point, the boiling point as well as melting point of metals usually high. Because they are hard in nature. Already I told, hard in nature. Okay, due to strength, that is why the boiling point and melting point of metals usually high. Isn't it? So this is about what physical properties of metals and non-metals. Sorry, non-metals is not over. We will discuss next point is non-metals. Physical properties of non-metals. Same properties we have to take. My dear friends, if you got these points, means usually you will get to the properties of non-metals. Very simple. Same properties are there, quite different. Isn't it? Physical properties of metals and non-metals. So we have completed metals only. Okay, especially here non-metals. So first property we have to. What is that first property? While studying about the physical properties of metals and non-metals, we took the first property, that is physical state. Okay, physical state, non-metals. Especially we are going to focus on non-metals. Okay, the physical properties of non-metals. We have completed physical properties of metals over. Now we are discussing non-metals. Isn't it? Yes. Physical state. My dear friends, usually the non-metals present in liquid state, solid state, and most of the non-metals, they are gaseous state. Okay, only few are there. Few are there, they are liquid state, and some are there solid state, and most of the non-metals, they are present in gaseous state. Okay, we already discussed the physical state in metals, whereas metals, they are solid state at a room temperature. These are also at a room temperature. Room temperature. Second point, that is hardness. Hardness. Okay, my dear friends, usually soft in nature. Most of the non-metals usually soft in nature, whereas non-metals hard in nature. That's all. Just comparing with metals. Okay, very simple. Next, third property. After this, one more property we have discussed. That is what? Lustrous. Okay, my dear friends, non-lustrous. It means they are dull in nature. Dull in nature. They don't have any shining property except iodine. Except iodine. Okay, iodine is shining in nature. Isn't it? Iodine is shining in nature. Lustrous. Yes? Yes, my dear friends, physical state, hardness, lustrous. Then fourth property, you know very well, that is malleability. It means usually they are soft in nature. They are soft in nature. Isn't it? Brittle in nature. Brittle in nature. Usually the non-metals, they are non-malleable. Okay? Non-malleable. Malleability property. Non-malleable. Isn't it? Because they are soft in nature. Due to soft in nature, they are non-malleable. Ductility property. Ductility also same property. Non-ductile. Non-ductile in nature. Non-ductile. Because we can't make any wire, we can't make any sheets because of this property, soft in nature. Yes, and especially they are in a liquid state and gaseous state. Only few are solid state. Isn't it? Yes. So this is about what regarding the physical state, hardness, lustrous, malleability. Next, ductility. So these are the properties. Next, sonorous. Sixth one, sonorous. Yes, sonorous means you know very well. Metals can make sound. Metals can make sound, whereas non-metals do not make any noise, any sound. Okay. This property, sonorous, means metals can make the sound, but non-metals cannot make the sound. It is a property in which can make the sound, but here non-metal cannot make the sound. Isn't it? Non-sonorous. 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 Isn't it? Okay. After this, one more property is a conductivity. My dear students, hope point is clear. Yes. Next property is what? Conductivity. Conductivity. Seventh one, conductivity. My dear friends, non-metals usually they are poor conductor of heat and electricity except graphite. Graphite can conduct the electricity. It is a non-metal, it can conduct the electricity. Isn't it? Next, last one, you know very well, my dear friends, MP and BB. Okay, usually metals are boiling point of metals, and boiling point of metals and melting point of metals are high, but in case of non-metals they are low. Melting point and boiling point usually low because of softy nature, because of liquid state, and only one non-metal is there, that is liquid state, that is bromine. Bromine also we can pronounce, bromine or bromine. Okay, this is the non-metal present in liquid state. You should be remember this point. Okay, yes, my dear friends, we have completed only physical properties of metals and non-metals. Isn't it? Hope point clear. Today we have completed 3 points. First point, occurrence of metals and non-metals. Second point, metalloids. Examples also I have given. Third point, physical properties of metals and non-metals. Yes, my dear friends, today we will wind up this class here only, and tomorrow our next class we are going to discuss chemical properties of metals and non-metals. We will discuss. Okay, take care. Bye bye. Sure, sir.